Hello, I welcome you all to this another interesting screencast. The problem reads, determine the coordinate direction angles of force F1. In the second problem, determine the magnitude and coordinate direction angles of the resultant force acting on the eyebolt. Both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Benam. Alright, let's draw the components of these particular forces. Let's start with F1. F1 to have a component on the XY plane. Then later on, this component will be mapped on the x-axis like so. And another one will be mapped on the y-axis like so. And then we have F2, which is in the ZX plane. We'll have a component mapped on the y-axis like so. Let me draw it like so. And then we'll have another component mapped on the z-axis like so. Alright, so let's write down these particular forces. So this one is just going to be equal to F1 times the run, which is a 4, divided by the hypotenuse 5. So like I said, this is going to be mapped to the x-axis, and here we're going to have F1 4 divided by 5, and then cos 30, and then we'll have this one mapped there like that, and then this one is just going to be equal to F1 4 divided by 5 sine 30. Alright, then here we have F2 mapped on the y-axis. This is cos 45, and then here we'll have F2 mapped on the z-axis. This one will be sine 45. Right, so we have all the components. Sometimes I prefer drawing a table. Not that this is what we are supposed to do. You don't have to do this. I prefer it myself to draw a table. Okay. So let's draw a table here so that we feed all this information in this particular table. So 1, 2, there are 2 of them, and then I have the section for resultant, like so, and then somewhere there, and then like so. Great. Let's feed that information there. So we have F like so, then we have F1, we have F2, let's call this FR. In these components, we have X component in newtons and Y component in newtons. F1, that's a 600 positive 600 by 4 divided by 5 cos 30, right? And then we have the y-axis. Y component is negative 600 by 4 divided by 5 sine 30. I forgot to indicate one component. Sorry about that. Let me create some space. Right. right, so we said this one is f2. This is f2 sine 45. We have also another component for f1 in this direction like so, and this one is equal to f1 times the rise. What's the rise? It's a 3 divided by, we're using this one here, right? It's a 3 divided by 5. Okay. So f2, what is f2? But here we have supposed to have extend this. Sorry, we need to extend this. We still have some components. All right. This is still have some components. Great. Like so, great. So this is Z in newtons. So in the z-axis we have a positive 600 by 3 divided by 5. f2 in the x-axis we have a 0. In the y-axis we have f2 positive 450 cos, what happened? Okay, 450 cos 45, and then in the z-axis it's 450 sine 45. All right, so basically this is frx. Okay, this is fry, and this is frz. All right, so we have frx equal to where is my calculator? That's 600 by 4 divided by 5 cos 30. So this gives us a 554.26 pounds. Okay, that's 600 by 4 divided by 5 times cos 30. Oh, come on, what happened? A 415.69 pounds. Okay, cos 30 times 600 times 4 divided by 5, 415.69, great. And then we have FRY, that's 0.5, so that is 300 by 4 divided by 5 plus 415 cos 45. So this we get a 78.20. All right, then we have FRZ. This is a 600 by 3 divided by 5 plus 415 sine 45. This is 678.20. Okay, I think this is okay. 450 cos 45, 78.19, and then 600 by 3 divided by 5 plus 450 sine 45, 678.20. All right, so let's get to the first case. Let's call this case 1. This is 2-75 2-75. So we have F1, we want the directional angles. Okay, all right, let's write F1 is just equal to is equal to 415.69 I minus that's 300 by 4 divided by 5 minus 240. So I'm just working out this component for F1. Okay, F1 there. All right, and then we have a plus 600 by 3 divided by 5, that's a 360. Okay, this is newtons. Okay, but I don't need this for now. So we already have the magnitude, therefore we know that the unit vector along this direction is just going to be equal to F1 divided by its magnitude. Okay, where its magnitude is already known, is equal to 600. So we have cos alpha 1 is equal to 415.69 divided by 600, and therefore alpha 1 is just going to be equal to 415.69 divided by 600 cos alpha, which gives us 46.15. And then we have cos beta 1 is equal to minus 240 divided by 600. Then beta 1 is just going to be equal to minus 240 divided by 600. Cos inverse of that, we get a 113.58. 113.58 minus 240 divided by 600, cos inverse of that, 113.58. And then here we have finally cos gamma 1 equal to 360 divided by 600. Then gamma 1 is just going to be equal to 360 divided by 600. Cos inverse of that, we get a 53.13 degrees. Alright, so these are the directional angles for case 1. Let's go for case 2. Case 2, that is 2-76. What do we have here? We are supposed to find the magnitude and of the angles of the magnitude and the direction angles of the resultant. Alright, so let's work out the resultant. Resultant is just going to be equal to the resultant is equal to 415.69 I plus these values here down, so one I'm just summing up, plus 78.20 J plus 678.20 K. Okay. Alright, let's find the magnitude. So we are using Pythagoras theorem. 415.69 squared plus 78.2 squared plus 678.20 squared, square root of that, that's a 799.29. Okay, so 415.69 squared plus 78.222 squared plus 678 squared, 678.2 squared, square root of that, 799.29. So then we have cos alpha r is going to be equal to 415.69 I divided by 799.29. We remove the I, we don't need I. Therefore, cos r is just going to be equal to 415.69 divided by 799.29. Cos inverse of that, this gives us 58.66 degrees. Okay, then cos beta r is going to be equal to 778.20 divided by 799.29. Beta r is just going to be equal to 78.2 divided by 799.29. Cos inverse of that, it just gives us 84.3839. So cos gamma r is just going to be equal to 678.20 divided by 799.29. So gamma r is just going to be equal to 678.20 divided by 799.29. Cos inverse of that gives us a 31.95. Alright, so I think we are done. We are done, I think so. 678.20 divided by 799.29. Cos inverse of that, 31.95. So let's outline the solutions. We have the coordinate angles for F1. So we have alpha 1, we have alpha 1, we have B1, we have gamma 1, and in the second case here we have the magnitude, okay, we have the magnitude. Let me just move it somewhere there, okay, and then we have alpha r, there we go. We have beta r, We have gamma error. Alright, I think this is about it. Let me just rewrite this one. I don't know what happened. I think this is about it. I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.